Hello everyone, welcome to engineering study, and this is my third lecture. In the first two lectures, we have learned about properties of soil mechanics, properties, and in my second lecture, we have learned about 6 index properties along with one workbook at the end of the video. All links are given in the description. Go to the description section and first listen to these two lectures properly and then come to my third lecture today. So today we are going to learn about unit weight. So what is unit weight? In my first lecture, we have learned a term density. Density of air, density of solid, density of soil. We have learned density term there. And what we have learned there, what is density? Density equals to mass by volume. Means kg per meter cube. Density equals to kg per meter cube. And from density we can get this term unit weight. And what is the unit of unit weight? Newton per meter cube. So simply we have to convert this kg to Newton. Meter cube is same. If we convert this kg to Newton, we will get the term unit weight. So how we will get from kg to Newton? From mass to weight or force. So for this we have to learn first Newton's second law of motion. Newton's second law of motion. In the Newton's second law of motion, we have learned that force equals to change of momentum. V minus u by d. V final velocity, u initial velocity, and Newton's. This is the Newton's second law of motion. So from here, F equals to V velocity by time means acceleration. M into A. Unit of M mass kg and unit of acceleration velocity unit meter per second by second meter per second square. So force equals to Newton equals to kg into meter per second square. So if we multiply this, multiply acceleration with kg, then we will get the term Newton. So first kg per meter cube into acceleration equals to Newton per meter cube. Kg into acceleration will be Newton. And what is this acceleration? This is actually gravitational acceleration. This is a constant 9.81 meter per second square. Due to the gravity, the acceleration value will be 9.81. This is a constant value. So if we multiply this, kg into 9.81 by meter cube equals to Newton per meter cube. So this is the very basic thing. Okay. So now we will learn how we apply this thing. We know in my first class what is the density of water? Rho W equals to 1000 kg per meter cube. And if we have to convert this density to unit weight, what we have to do? 1000 into 9.81 kg per meter cube into meter per second square. Kg per meter cube for this term, 9.81 meter per second square for this term. So equals to 9810 kg meter per second square. Mass into acceleration equals to Newton by meter cube. Okay. And now if we convert it from Newton to kilonewton, we have to 9810 by 1000 into 1000 Newton per meter cube. So this means 9.81 or 1000 Newton means kilonewton per meter cube. So unit weight of water, unit weight 9.81 kilonewton per meter cube. So unit weight of water 9.81 per kilonewton per meter cube. So gamma W, density rho W, unit weight gamma W, 9.81 kilonewton per meter cube. So I think now this is clear what is the difference between density and unit weight. Now we will go for the each term about unit weight. So what we have learned about density and unit weight, make this part, that part as a note of at your notebook. Write down a note there and write the whole thing. And your main note is starting from here, unit weight, bulk unit weight, dry unit weight. So that part actually conceptual part of unit weight. So at your side of your workbook or notebook, write that down for your conceptual part. And main note is starting from here, bulk unit weight and dry unit weight. So first is the bulk unit weight. Bulk unit weight, what I have told you that whatever be the term, first know what is its name. In the technical subject, if you understand the name, you will understand the topic also. Okay. So first, bulk unit weight. Bulk unit weight here, what is we are getting? Bulk. Bulk means total. What is total unit weight? That means total weight by total volume. Total weight means a soil as, if we consider as a soil as three-phase system, solid, water and air. So what is the total weight? Weight of solid plus weight of water plus weight of air, but weight of air equals to 0, negligible. So we don't consider the weight of air. So weight of solid plus weight of water by total volume. Volume of solid by volume of void. Volume of void means volume of water plus volume of air. Okay. So this is the bulk unit weight. Bulk unit weight generally deals with the total thing, total soil mass. Now dry unit weight. Dry unit weight, what this name signifies, dry. That means there should not be any water part. No water is there. That's why dry, no water is present. So we have to remove the water. And how will remove the water? If we put a soil in a oven, the water will generally evaporate. So what will be the present situation of that soil? There will be solid and air. So solid and air means weight of solid plus weight of air. This will be the weight of air. Weight of air is negligible. So weight of solid by volume of solid plus volume of air, as there is no water. So this is the dry unit weight. Write down a note here, note part. Dry weight should be taken after oven drying of soil. Dry weight should be taken after oven drying of soil. Second part, note point 1, note point 2. Dry unit weight of soil is an indicator of denseness of soil. Dry unit weight of soil is an indicator of denseness of soil. Note point 3. If gamma dry is more, it means soils are packed densely. If gamma dry is more, soil are packed densely. So now we will understand these three terms. In the first term, what we have learned, gamma dry should be taken after oven drying. That's very basic thing. If we have to make the soil dry, we have to put the soil in oven to evaporate the water. So that after that we can get the dry unit weight. And second thing, dry unit weight of soil is an indicator of denseness of soil, as dry unit weight only deals with the solid particle. Here in the three-phase system of soil, solid, water, air, as the water is absent here, so gamma dry is only deal with the solid particle. So if gamma dry value is more, these two things here, let us guess that here unit 5 Newton per meter cube, here 10 Newton per meter cube, value of gamma dry 5 Newton per meter cube, 10 Newton per meter cube. That means in 1 meter cube space 5 Newton of solids are there, like this. But here value is 10 meter cube. In 1 meter cube space, if same pot, the denseness will be more here. So if gamma dry value is more, the soil will be more dense. And here we only deal with the solid particle. So there will be solid particle will be more dense if gamma dry value is more. So number 2 and 3 describes here. So I think the whole 3 point is clear now. Now we are going to learn about saturated unit weight. First look into the term saturated. Saturated means it deals with the water. How much water present there. Saturated. We have also learned a term degree of saturation in my second lecture. Degree of saturation. Yes. What is the definition of this? Volume of water by volume of void. This term also deals with the water part of the soil. So if degree of saturation is equals to 0, that means there is no water. Volume of water is 0. That means that will be a dry soil. If S equals to 100%, that means there is no air, as volume of void means volume of air plus volume of water. If S equals to 100%, then this total volume of void will be volume of water. Then VW by VW will be 1, then this will be 100%. This is called fully saturated soil. This is gamma sat. Gamma sat. So in any problem in soil mechanics, problem, these things is very common. This is a total soil, and here will be given a water table. So there are two type of soil. One is dry, one is saturated. Above soil will be gamma dry, and bottom soil will be gamma saturated. Gamma saturated means soils under water table. Unit weight of soil under water table. That is the value of gamma saturation. Or if the soil is saturated by anyhow, then the value of the unit weight of that part of soil is gamma saturation. The most important term, submerged unit weight. So first look into the term submerged, and why this term is important. Submerged. So first know why the submerged term is used. Submerged means what? Submerged means a soil which is under water. Submerged soil which is under water. And why this term is important? Because if you start digging from the ground level, this is the ground level, start digging, a situation will must come where the groundwater table will exposed. The groundwater table will be exposed. Okay, if you dig a well in your home, at a situation will come when the groundwater table will exposed from the upper face. So but in case of soil mechanics, this is a very major issue regarding the strength and security of the soil, as it affects the strength of the soil. We have learned from my above two lectures, we know that how water is important in case of soil mechanics. Dry unit weight, saturated unit weight means the presence of water defines so many terms in index property. If water is not present, that is called dry unit weight. If water is present, that is called saturated unit weight. So water plays a major role in case of soil mechanics. So as it affects the strength of the soil, so we have to deal with this groundwater. Okay, so for this term has generated submerged unit weight. So the soil under the groundwater or under water will be deal with this term submerged unit weight. The soil under water or groundwater will be deal with this term submerged unit weight. Submerged means the soil is submerged under water. So the basic thing is clear. I think the submerged unit weight means we have to deal with the soil under water, not the above part of the groundwater. Write it down, submerged unit weight. So what is the definition of this? When the soil is submerged below the groundwater table, then the buoyancy force act, and magnitude of this force equal to the water displaced by the soil. What does that means? That means, guess, you are standing beside a pond, and the depth of this pond is 3 meters. Okay, and if you jump into the pond, you will start going down, but the water present here will give you resistance from the opposite direction. So this resistance is called buoyancy force. And as you have to go down, some amount of water you have to displaced to make a space for you to go down, and the displaced water is equals to the magnitude of that buoyancy force. This is a basic part of fluid mechanics. So the magnitude of the force is equal to the water displaced by the soil. Here as we deal with the soil, so here we have to consider soil. So the basic thing is, if we jump into the pond, the water will give you the resistance from the opposite direction. That force is called buoyancy force, and as you have to go down, you have to displace some water from beside to make a space for you, and the displaced water will be equal to the magnitude of that buoyancy force. Okay, now what is submerged? The definition of submerged unit. What is the definition of submerged unit? Defined as the ratio of effective weight of the soil mass to the total volume of soil mass. Effective weight means the weight of you minus the buoyancy force minus the resistance of the soil. If your weight is 10 kg and the buoyancy force is 1 kg, then your effective weight will be 10 minus 1, 9 kg. 9 kg by your total volume will give the submerged unit weight, and replace U by the soil particle, and you will get the submerged unit weight of soil. Now look at here, effective weight. Effective weight equals to saturated weight minus buoyancy force. Effective weight, saturated weight means the weight of the soil under the water, as soil particle consists solid, water and air, and here the air will be fully removed. The void due to the air will be replaced by the water. So this will be a fully saturated soil when the soil is under water table. So saturated weight of the soil minus, if this is a soil particle, a buoyancy force will act opposite to the soil if the soil particle is under water table. So the minus buoyancy force. So what is the effective weight? Saturated weight minus buoyancy force. Now divided by volume, saturated by volume. So now effective weight by volume. Look at here. Effective weight of soil mass to the total volume is called submerged unit weight. So it's called submerged unit weight, gamma sub. And saturated weight by volume is called saturated unit weight. We have just learned about that. Saturated unit weight. Now FB by V, buoyancy force, what we have learned, what is the value of this buoyant force is equal to the weight of the water displaced by the soil. That means it is the weight of the water, WW, weight of the water displaced by the soil by total volume. So weight of water by volume, that means gamma W, unit weight of water. Unit weight of, what is the definition of unit weight of water? Weight of water by total volume. So this is the unit weight of water. So what we are getting now, gamma submerged equals to gamma saturation minus unit weight of water. Mark it as a 3 star. This is very important. And after this lecture, there will be no workbook. In my 4th lecture, there I will give you workbook. And first solve the workbook 1, which is given after my lecture 2, and then try to solve workbook 2, which will be given in lecture 4. Okay, thank you.